Hi, this is Dr. Steve Piloff. I want to talk about special two-part problem, type of two-part problem. Part one involves saving with an annuity or annuity due until you get so that you have accumulated some money, and then you use the save funds to withdraw either with an annuity or you can keep going forever and ever and ever as a perpetuity, and the perpetuity can be fixed or can grow. One type is basically all the information in part two is provided. So you basically know how much money you're going to need as of what we call the new time zero. So at some point in the future, when retirement starts or college starts or you want to start, scholarship, you're going to need to have some money. All that information is given. Then in part one, you need to figure out how much you need to save each period with an annuity or annuity due in order to have the amount that is necessary to fund the situation provided with part two. A couple of notes. First, even though it's called part one and part two is done first. Figure out how much you're going to need. Part one, figure out how much you need to save in order to get how much you need. Timelines, very, very, very useful. And you can think of n as the pivot point. So time n, that is what we're going to save towards, and that's going to be the new time zero for the second part. So you can think of time n as the pivot point. So let's take a look at an example. How much does Bet need to save each year to have enough to pay for college? Well, she's going to pay $19,000 per year to her college for 4 years. And the first payment's due when she starts college, and she starts college in 3 years. So she's going to need 19,000 in 3 years, 4 years, 5 years, and 6 years. Expect a return of 19.3%. So in order to get enough money to pay for college, she's going to make equal annual contributions for 3 years. And the first one will be in 1 year. So in 1, 2, and 3 years, she's going to put money into an account, and then she's going to take the money out in 3, 4, 5, and 6 years. So let's put that all in a timeline. So again, 19,000 per year. And again, we represent it as positive because she's going to need to pay this, but in order to do that, she's going to need to withdraw the money from her account. So she needs that account to give her 19 in 3 years, 19 in 4 years, 19 in 5, 19 in 6. Our new time zero is time 3 because she's going to be saving for 3 years. So right when she starts college, she'll pay 19, 19, 19, and 19. She'll make equal annual contributions for 3 years, starting in 1 year. So she'll save, she'll save, she'll save. Then in 3 years, she'll need to have enough money to be able to pay 19 right away, 19 in a year, 19 in 2 years, and 19 in 3 years. So that lays out what's going on. So how do we want to approach it? We're going to want to figure out present value of an annuity due with 4 payments of 19,000, and that'll determine how much we need to have, how much she needs to have in that account, and then figure out how much she needs to save in order to have that amount. So again, note that the new time zero for part 2 is 3. We've already talked about that. And again, the 19,000 cash flows are positive because even though she's going to be paying 19, the way we're viewing it is that she needs to be able to take the 19 out of the account so she has it to pay the college. So again, 19 plus 19 over 1.093 plus 19 over 1.093 squared plus 19 over 1.093 to the third can be viewed as the present value of a 4-period annuity due. There's 4 payments, 19,000, begin mode. So again, starting right away, she needs to have, when she heads off to college, $66,839. That's how much she needs in 3 years. If she has that, she can take out 19, earn some interest, take out another 19, earn interest on what's left, and take out 19, earn interest, and take out the final 19. So part 2 is, okay, we know she needs 66,839. How much does she need to save here, here, and here? So if we're going to be saving with a 3-period annuity, we know it's an annuity because her first payment's 1 period after time 0, and she needs to have 66,839. She needs to put away $20,330 per year. If she puts in 2330, 2330, 2330, she'll have 66,839, which is enough for 19, 19, 19, and 19.